Installing a new 4-wire dryer outlet next to an existing 3-wire dryer outlet creates a potential hazard if both dryers are plugged in simultaneously. A ground loop can form because the new dryer's grounding wire, connected to the 4th pin of the 4-wire outlet, can create a closed loop with the old dryer's neutral wire, connected to the white wire in the 3-wire outlet. This ground loop can create an electrical shock hazard. If there is a fault in the new dryer, the electrical current can take the path of least resistance, which is through the grounding wire and the old dryer's neutral wire. This can cause an electrical shock to anyone who touches the old dryer or other metal objects connected to it. To avoid this hazard, several steps must be taken. Firstly, replace the old 3-wire outlet with a 4-wire outlet. This ensures that both dryers have a proper grounding path. Secondly, disconnect the old dryer. Unplug the old dryer from the 3-wire outlet and turn off the circuit breaker or fuse that powers it. Thirdly, verify the grounding of the 4-wire outlet. Use a multimeter to ensure that all 4 wires, hot, neutral, ground, and bonding in the 4-wire outlet are properly connected. Once these steps have been taken, it is safe to plug both dryers into their respective 4-wire outlets. If there are any doubts or a lack of comfort in performing electrical work, it is highly recommended to hire a qualified electrician to handle these modifications safely. Understanding the reasons behind these precautions is essential. The older 3-wire system used the neutral wire for both carrying the return current and providing a grounding path. This was permissible under older electrical codes but is no longer considered safe for new installations. The 4-wire system separates the neutral and ground wires, providing a dedicated path for fault currents to return to the source without energizing the neutral conductor. When a new 4-wire outlet is installed near an existing 3-wire outlet, a potential difference can exist between the ground and neutral conductors, particularly when both dryers are operating. This difference in potential can create the ground loop, allowing current to flow through unintended paths. If a fault occurs in the new dryer, the current will seek the path of least resistance back to the source. In a properly wired 4-wire system, this path is through the dedicated ground wire, which trips the circuit breaker, cutting off power to the dryer. However, with the presence of the old 3-wire system, the fault current might also flow through the neutral wire of the old dryer, potentially energizing the appliance chassis and creating a shock hazard. Replacing the old 3-wire outlet with a 4-wire outlet eliminates the shared neutral and ground connection, ensuring that each dryer has its own dedicated grounding path. This prevents the formation of a ground loop and reduces the risk of electrical shock. Disconnecting the old dryer is another critical step. Even if the old dryer is not in use, it can still create a potential hazard if it is plugged into the 3-wire outlet. The neutral wire in the old dryer is still connected to the electrical system, and if a fault occurs in the new dryer, current can flow through the old dryer's neutral wire, potentially energizing the appliance. Unplugging the old dryer and turning off the circuit breaker or fuse that powers it eliminates this potential hazard. Verifying the grounding of the 4-wire outlet is essential to ensure that the new outlet is properly wired and that the grounding system is functioning correctly. Use a multimeter to check the voltage between the hot wire and the ground wire, the hot wire and the neutral wire, and the neutral wire and the ground wire. The voltage between the hot wire and the ground wire should be approximately the same as the voltage between the hot wire and the neutral wire, typically 120 volts or 240 volts, depending on the electrical system. The voltage between the neutral wire and the ground wire should be close to 0 volts, indicating that the grounding system is properly connected. Also, check the continuity between the ground wire and the metal chassis of the dryer to ensure that the appliance is properly grounded. If any of these measurements are incorrect, there may be a wiring problem that needs to be corrected before using the outlet. It is also important to ensure that the circuit breaker or fuse that powers the dryer is properly sized for the appliance. The dryer's nameplate will indicate the maximum current draw of the appliance. The circuit breaker or fuse should be rated for at least this current, but it should not be oversized, as this can prevent it from tripping in the event of a fault. If the circuit breaker or fuse is too small, it will trip frequently, interrupting the dryer's operation. If the circuit breaker or fuse is too large, It may not trip in the event of a fault, potentially leading to a fire hazard. When replacing the 3-wire outlet with a 4-wire outlet, it is important to follow all applicable electrical codes and regulations. The National Electrical Code, or NEC, provides detailed requirements for electrical wiring and grounding. Consult the NEC for specific requirements in your area. It is also important to use the correct type and size of wire for the new outlet. The wire should be rated for the voltage and current of the circuit, and it should be properly sized to handle the load. The wire should also be properly insulated to prevent shorts and ground faults. When connecting the wires to the outlet, be sure to use the correct terminals. The hot wire, typically black or red, should be connected to the hot terminal. The neutral wire, typically white, should be connected to the neutral terminal. The ground wire, typically green or bare, should be connected to the ground terminal. Be sure to tighten the terminal securely to prevent the wires from coming loose. Once the new outlet is installed, it is important to test it to ensure that it is working properly. Use a multimeter to check the voltage between the hot wire and the ground wire, the hot wire and the neutral wire, and the neutral wire and the ground wire. Also, use a receptacle tester to check the wiring of the outlet. The receptacle tester will indicate whether the outlet is properly wired and grounded. If the outlet is not properly wired, it is important to correct the wiring before using the outlet. The grounding system is a critical safety feature that protects people from electrical shock. It provides a low resistance path for fault currents to return to the source, tripping the circuit breaker or fuse and cutting off power to the circuit. Without a proper grounding system, fault currents can flow through unintended paths, potentially energizing metal objects and creating a shock hazard. In addition to the safety benefits, a proper grounding system also helps to protect electronic equipment from damage. Grounding provides a stable reference point for the electrical system, preventing voltage fluctuations and surges that can damage sensitive electronic components. When working with electrical systems, it is important to take precautions to protect yourself from electrical shock. Always turn off the power to the circuit before working on it. Use insulated tools and wear rubber gloves and shoes to provide insulation from electrical current. Never work on electrical systems in wet or damp conditions. If you are not comfortable working with electrical systems, it is best to hire a qualified electrician to do the work. Electricity can be dangerous, and it is important to take precautions to protect yourself from electrical shock. Understanding the differences between 3-wire and 4-wire systems and taking the necessary steps to ensure proper grounding are essential for electrical safety.